Hello everyone and welcome to day 29 of the Jamb Physics in 40 Days series. This series is brought to you by Oyalen, where we believe that when you dedicate within 30 to 45 minutes of your time daily, you should be able to get all the necessary tools that will help you ace Jamb Physics. So if you're a candidate who is preparing to take the Jamb exams and one of the subjects you have selected for that exam is physics, then these videos are specifically made for you. So trust me, you really want to check out all the videos in this series from the start to the end. So don't just start here, pick it from day one and follow the series on to the end. It's only going to take 30 to 45 minutes of your time daily, and if you are properly dedicated to it, we assure you that you are definitely going to ace your next Jamb Physics exams. And please, we would like to implore you that while you are at it, please click the subscribe button. That will be your way of helping us to continue to make more helpful content like this. And also do not forget to share the content and also like the video so that we can reach a wide range of audience who actually need this video. So please like and continue to share. And then to put in more practice, I advise that you download the Exam Fund app. The link to download the app is in the description box of this video. The app is created in such a way that it makes your learning experience a lot more fun. As you solve questions, you get to gather points and even earn a little bit from it. That way you are not just learning, but you can earn while you learn. So it is both exciting and rewarding. So you really want to try it out. Click the link to download. And if you have any question at all, perhaps on what we are doing so far, or perhaps during your study time you came across something that you would like some help with, please put it in the comment section and we will definitely attend to all your comments. Thank you very much. Now, to the business of day 29, what we'll be looking at is electric cells. Now, what Jamb expects of every candidate taking the exams to understand when it comes to this electric cells topics are listed here. They expect that you should be able to define simple voltaic cells and be able to state the defects of simple voltaic cells. Now, what a cell should entail of is what we call the electrodes that are in electrolytes and then produce current. Now, there are some defects you can find there. They expect to be able to define them. Defects such as what we know as the local action and what we know as polarization. You should be able to describe these defects as well as define what electric cells are. Then they expect you to be able to mention types of cells, whether it's wet cells or dry cells. And some of those cells include what we know as the Daniel cell, the Declanche cell, the lead acid accumulator, the nickel ion, the lithium ion, and the mercury cadmium. Like for example, the lead acid accumulator is what is used in like your car. The car battery is a lead acid accumulator. The mercury cadmium battery is that button-like kind of battery that is used in watches and the likes like that. So you should be able to tell those kind of batteries apart and you should be able to tell the differences between them. Why would you prefer this for a particular action as opposed to the other? And then you should be able to also mention the ways by which you can perform maintenance of cells and batteries. And not just that, you should also be familiar with arrangement of cells, whether it is series arrangement, whether it is parallel arrangement, or a combination of series and parallel. And not just that, you should also be able to tell the effect of arranging batteries in series or in parallel. Now, it depends on what you want to use the battery for. If you want a particular voltage but more power, you have to arrange in parallel. But if you want more voltage, then you have to arrange in series, because when you arrange them in series, the voltage, EMF rather, will add up at that point. And then when you arrange in parallel, they maintain the same EMF for all the batteries that you have arranged. So there's a reason why they are arranged in specific ways. You should be able to tell that and solve simple calculation based on arrangement of cells and batteries. Now, you should also be able to calculate the efficiency of a cell. I've put out a simple equation for that. Efficiency is the useful power output of the cell over the total power output multiplied by 100%, and that is how it is calculated. Now, this video is for the purpose of preparing you for Jamb exams. So what we will be doing is solving past questions and always highlighting some facts that you need to know, and also giving you tips that help you answer the questions we are solving with greater accuracy in case you find questions like that. They may not be exact, but there are some tips we will give you that will help you solve questions that look like that or are in the same topic as that. So you need to pay attention while we go across that. But if you want better detail of this, you can check out the video on our channel where we explain electric cell in greater detail. Now that video is for the purpose of explaining the topic in detail. So there we will look at each of these topics with greater precision. We talk about every little detail that you should know when it comes to this topic, so you don't want to miss it. And when you check it out, please don't forget to also share it so that we can reach more people who need understanding on this topic. However, if you're ready, what we'll do now is to solve some past questions. So get your materials ready and let's answer some questions. This question says, a safety precaution designed to prolong the life of a lead acid accumulator is. Now, of these 4 options here, only one of them is correct, which means the other 3 are wrong. So what I'll be doing is I'll be telling you why they are wrong and then why the correct answer is the correct one. So that in case if this question is flipped around when you're writing your exam, you will know what to do. So if you are asked what is the thing that you should never do when you're trying to prolong the life of a lead acid accumulator. So let's look at the options and then I explain as we go. Now option A says by topping up the cell with concentrated acid. Now you see, when you have added the concentrated acid to a lead acid accumulator, what happens during use is that the water content of the acid will evaporate during use and the specific gravity of the acid remains the same. So the only thing you should actually top up with is distilled water, because you don't want to change the specific gravity of that acid. So you only top with distilled water, not with acid, because that will actually affect the specific gravity of the acid in the battery. Now B says the use of naked flame when charging the battery. Now when you are charging the lead acid accumulator, what happens is that there's always a release of hydrogen gas, and that is flammable. So by the time you use direct flame, it will lead to a real fire hazard. So it is not even advisable, not even for you, much less the battery. Now option C says keeping the specific gravity of the electrolyte within a specific range. Now this will actually prolong the life of the lead acid accumulator, because what you want to do is to maintain the specific gravity of the acid to ensure that the battery continues to work at that level. You don't want it to either reduce or increase. This is also the reason why we usually top with water and not with acid, so you do not affect the specific gravity of the electrolyte. And then finally option D says by connecting wires to the terminals directly when testing the level of the charging. Now this is risky because it can lead to a short circuit or a spark and can lead to a lot of hazards that we can't even get into all of them one after the other. So but we know that it can really lead to a hazard, so it does not prolong the life of the battery. So we see that options A, B and D will not prolong the life of the battery, but they can lead to real hazards. Option C is the only one that helps to prolong the life of a lead acid accumulator. So the answer to this question is C. Lead acid accumulator consists of. Now I'm not only going to pick the answer, but I'll also tell you why the others are incorrect. So please pay attention, just in case the question is flipped. You will always know which one to go for. So option A says lead as the positive electrode. Now this is wrong, because the positive electrode of a lead acid accumulator is lead dioxide. Lead 2 oxide, or this is what should be the positive electrode. Now option B says lead acid as the negative electrode. That is wrong, because here we need pure lead as the negative electrode. Pure lead is what is used as the negative electrode of a lead acid accumulator. Now option C says hydrochloric acid, that is HCl, as the electrolyte. Now, HCl does not contain the right sulfate that is required for a lead acid accumulator, so this is also wrong. And then option D says tetraoxosulfate 6 acid, which is the IUPAC name for sulfuric acid. So another name for this is sulfuric acid. And it contains the right amount of sulfate that is required for lead acid accumulator. So the correct answer is option D. Which of the following has the lowest internal resistance when new? Let's check out the options. Option A says Leclanche cell. Now the Leclanche cell is actually designed in the cases where you need low current outputs, like when you need a battery for wall clocks or for remote controls and the like. So the perfect batteries for those kind of situations is the Leclanche cell because it always provides low current output. However, it has a moderately high internal resistance when you compare it to the accumulator. Now, option B says the Daniell cells. Now, the Daniell cell is also a typical laboratory battery, but the problem here is that it has a high internal resistance. Now, for option C, the touch battery, which also works just exactly like the Leclanche cell, is actually built based on the same design as the Leclanche cell. So it is used to provide low current output, so from low to moderate current output in the case of the touch battery, like batteries such as the Tiger batteries and Duracells and the likes. They provide low current output to moderate current output, but they also have a sufficiently high internal resistance when you compare them to the accumulator. Now, of all this four, the only one with the low internal resistance is the lead acid accumulator, which is why it is the one that is mostly used when you are doing current electricity experiments in the physics lab. So the answer to this question is option D. Which of the following is correct about an electric cell? And then when we consider the options, you see primary cell produces a large current for a long time, secondary cell has a very high internal resistance, primary cell has a very low internal resistance, and secondary cell has a very low internal resistance. Now, to help you understand how to pick your answer here, I'll give you an example each of the primary cell and the secondary cell. Now, take note of this. For primary cell, an example will be the Leclanche cell. And then secondary cell as an example as lead acid accumulator. So when you understand the workings of these two different types of cells, it helps you to easily pick your answer. Now, option A says primary cell produces a large current for a long time. Now, we know that the Leclanche cell is primarily produced to give you low current output. I gave an example like batteries that are used for wall clocks or remotes require low current output. So that means that option A is totally wrong because primary cell produce low current output, not large current output. So this is out. Now, option B says secondary cell has a very high internal resistance. And we know that the lead acid accumulator is used in the laboratory majorly because of its low internal resistance. So that means option B is wrong. Option C says primary cell has a very low internal resistance. Now the Leclanche cell produces low current output, but it has a sufficiently high internal resistance when you compare it to the lead acid accumulator. So that means option C is also wrong, leaving us with only option D, which says secondary cell has a very low internal resistance. And the lead acid accumulator is mostly used in the lab because of its low internal resistance relative to other types of cell. So the correct answer here is option D. A cell of internal resistance R supplies current to a 6.0 ohms resistor and its efficiency is 75%. Find the value of R. Now, to solve questions like this, here's what you do. Now, you have to recall that efficiency equals power output over total power input. Okay, now but there's another equation we can use for this. So we can equate this to external resistance over the same resistance plus internal resistance of the cell. This is how we can also do useful power output over useful power input, because this way you see that every other parameter is going to cancel out and then you are left with this. So what I'm going to do is I'm going to equate efficiency with this. Since we have the efficiency at 75%, that's 75 over 100, which gives us 0.75. Now that equals the resistor that it supplies current to is 6 ohms. So 6 over 6 plus R. So now we have to solve for R. Now what we'll have is 0.75 into 6 plus R, and we equate this to 6. Now from here we can see that this will multiply to give you 4.5 plus 0.75 R, and this equals 6. Now when you collect like terms, 0.75 R equals 6 minus 4.5, which will actually give us 1.5. So dividing both sides by 0.75, the internal resistance R is 1.5 divided by 0.75, and this will give you 2.0, and it is measured in ohms. So the correct answer here is option D. If you are yet to be subscribed to the channel, kindly take a moment to click the subscribe button. That will be your way of helping us to continue to make more helpful content like this. And also do not forget to like the videos as well as share them with your contact list so that we can reach a wide range of audience that are in need of helpful content like this. And if you have any question at all you would like to ask us, please put them in the comment section. Whether it's about what we are doing presently or if it's about something you found while you were studying and you would like help with. We are always ready to listen to your questions and we'll definitely attend to all of the comments you send our way. So please keep them coming. We will definitely attend also to yours. And don't forget that since practice is what makes perfection, ensure that you continue to practice. And one sure way to enjoy your practice time is to use the Exam Fund app. So please click the link in the description box of this video to download the Exam Fund app today so that you too can infuse a bit of fun into your practice time. Trust me, the app is created with you in mind to ensure that you enjoy your study time. So you get to solve questions in any subject of your choice while earning points, and it's also rewarding as you get to earn some money while you learn. So please download today and enjoy. Please drop a comment about the app in the comment section of this video and be sure to attend to all of your comments. Thank you very much in advance for doing this. Now, to get to this question on the board now, the question says a cell of internal resistance 2 ohms supplies current to a 6.0 ohms, that's 6 ohms resistor. Now the efficiency of the cell is, that is, we have to find the efficiency of this cell. Now take note, internal resistance is 2 ohms and the resistor it is supplying current to is 6 ohms. Now this is what we do. Solution. Remember, small r is 2 ohms, big R is 6 ohms. Now efficiency would be big R over the sum of the two, and then we multiply this by 100%. Now this is 6 over 6 plus 2 times 100%. Now what this will give us is 6 over 8 times 100%, and of course we see that 2 goes here 3 times, 2 goes here 4 times, and 3 over 4 is 0.75. Now when you multiply that by 100, you come up with 75.0%. So the correct answer to this question is option D. Which of the following instrument is most accurate for comparing electromotive force EMF of two cells? Now when you look at the options provided, you can immediately rule out option B and option C. Reason being that the meter rule is not even used for electrical measurements, but it's used to measure distances in the lab. And then galvanometer is used for measuring current and also direction of current. So it does not measure electromotive force or voltage. So that leaves us with A, which says voltmeter, and B, which says potentiometer. Now, the reason why the answer to this question is D, potentiometer, is because potentiometer does not draw current. Okay, so let's note that here. Does not draw current during measurement. Okay, while in the case of voltmeter, draws small current during measurements. Okay, so now that we know this, when the voltmeter draws a small amount of current while taking the measurement, what will happen is, because of the internal resistance of the two cells, in this case, it's going to give you a value of EMF that is slightly lesser than the actual value. Whereas in the case of potentiometer, it does not draw current, so as a result, it's going to give you the exact value of the EMF of the two cells. That way you can easily compare them. So the correct answer is option D. A good electric cell should have the following, except, now when we consider the options, it's very easy to spot out the odd one here, because a good cell should have a minimum of polarization. Because one of, in fact, the two major defects of cell is local action and polarization. So the lesser the local action, the lesser the polarization, the better for a cell. So a good cell should have a minimum of polarization effect. B, a good cell should have a long lifespan, should be able to provide current over a long time. And then C, it should be cheap and safe electrolyte. That is, when the electrolyte is cheap and is easily available and is also safe to use, it makes it a good cell. But option D says high cost and danger. That means it will harm not just the user, and you may not be able to even find the materials to make such a cell because of the high cost. So that makes it a bad electric cell. So the correct option here is D. In this question, we can kill 4 birds with just one stone. The question itself asks us to identify the depolarizer, the positive and negative electrodes of a Daniell cell. Now, for a Daniell cell, the depolarizer is copper sulfate, the positive electrode is copper, while the negative electrode is zinc. That means the correct answer is option A, right? But let's see what option B, C, and D describe. Now, when the depolarizer is manganese dioxide, the positive electrode is carbon, and the negative electrode is zinc, you are referring to a dry cell here. When the depolarizer is sulfuric acid, the positive electrode is lead oxide and the negative electrode is lead. This describes the lead acid accumulator. Now, when the depolarizer is potassium hydroxide, the positive electrode is nickel and then the negative electrode is iron. This is known as the nickel ion cell. Another name for this is the Edison cell. So now you can identify these 4 types of cell in case if the question is flipped. In this time, we're trying to identify the Daniell cell. So if the question is asked for a dry cell, for a lead acid accumulator, or for a nickel ion or Edison cell, you would know the answer. But for this question, the answer remains option A. If you're yet to be subscribed to the channel, please take a moment to click the subscribe button, and also you can hit the notification bell icon so that you get alerted every time we put out a new content. And please do not forget to like the videos and also share them to your contact list so that we can reach a wide range of audience that are in need of content like this. So please keep sharing, keep liking the videos, and to make your practice even more fun, you can also do that with the Exam Fun app. The link to download the app is in the description box of this video. Click the link, download the app, and enjoy your study time. It's going to infuse fun into your study time, and it covers a wide range of subjects. So regardless of what subject you're doing, there's something there for you that makes your learning time even more fun. And if you have any question at all, perhaps on what we are doing, or perhaps during your study you came across something that you would like help with, please put it in the comment section and we will definitely attend to all of your comments. So keep them coming. Okay. Now, to answer this question that we have on the board, let's look at the details there. So we are told a radio is operated by 8 cells, each of EMF 2 volts. And they're connected in series. Now, when you connect cells in series, what happens is that the total EMF is the sum of all the cells that you have connected in series. So let's put that down here. Total EMF is supposed to be 2.0 volts multiplied by 8 cells, and that will give us 16.0 volts. Now we are told that if 2 of the cells are wrongly connected, now that is, they are connected in the reverse direction, that will mean that they will subtract the voltage from what we have. So let's find the EMF of those 2 that are in the reverse. Now, EMF of cells in reverse is 2 times 2.0 volts, which will give us 4.0 volts. So now the question is the net EMF. We're asked to calculate the net EMF of the radio. So net EMF would then be 16.0 volts minus 4.0 volts. And this would give us 12 volts. So the correct answer here is option C. Which of the following is an electrolyte? Now, before I pick the answer, let me explain this. Now, for a substance to be even considered as an electrolyte, it has to be polar in nature. And when it dissolves in water, it has to give you positive and negative ions. That it dissociates to give you ions, positive and negative. So now let's look at what we have in the options and then see if they dissociate to give us positive and negative ion, and therefore we can then pick which one is an electrolyte. Now option A says paraffin, which is a non-polar solution. So as a result, it does not even dissolve in water, so it can't even give you positive or negative ions. So it is not an electrolyte. Now, sugar solution on the other hand can dissolve in water, but when it dissolves, it does not give you positive or negative ion. That is, it does not dissociate into ions. So as a result, it is not an electrolyte. And the same goes for alcohol, because it will dissolve in water, but it does not give you ions. It does not dissociate into ions, leaving us with grapefruit. Now, grapefruit contains something known as citric acid. And if you define acid, it is anything that dissolves in water to give you hydrogen ion as its only positive ion. So that tells you that if you put it into water, it will dissolve into ions. So as a result, it is a useful electrolyte. So the correct answer here is option C. This question says, which of the following can be used to reduce local action in a Leclanche cell? Now, for the Leclanche cell, local action is due to the spontaneous corrosion of the zinc negative electrode due to impurities. So in order to limit this, you have to eliminate the impurities by using pure zinc as the negative electrode. So that means the correct answer is option B. A simple cell with mercury amalgamated zinc electrode prevents. Now, when we say mercury amalgamated zinc electrode, it means that the zinc electrode is coated with mercury. That way, it's able to cover up the impurities and reduce local actions. So the correct answer here is option A, which is local actions. Which of the following factors has no effect on the EMF of a primary cell? And then we have options such as temperature, size of the cell, nature of the plates, nature of the electrolytes. Now, in the case of temperature, when you change the temperature, it can affect the rate of chemical reaction, and as a result, that will affect the EMF of the cell. And then when you consider nature of the plates, different electrode materials leads to different types of voltages that is produced in the cell. So it affects the EMF directly. And the same thing with the electrolytes, because the electrolytes can affect the chemical reaction, which will therefore affect the EMF. The only thing that does not affect EMF in this case is the size of the cell. Well, it can affect the how long it lasts and things like that, but it does not affect the EMF directly. So as a result, the correct answer here is option B. The function of the system of granulated carbon mixed with manganese oxide in a Leclanche cell is to. Now, the reason why this is added to a Leclanche cell is because when you're running the Leclanche cell, there's usually hydrogen buildup at the positive electrode. Now, this is known as polarization. So this mixture reacts with the hydrogen ions, they react with it, thereby reducing the buildup of the ion. So it actually prevents polarization in the cell. But when we look at the other options that we have here, option A says to increase the EMF, and even though the Leclanche cell is typically 1.5 volts, the addition of this mixture does not increase the voltage or the EMF of a Leclanche cell. Now, option B says prevents local action in the cell. Now, local action can be prevented in Leclanche cell by either using pure zinc in the negative electrode or using mercury amalgamated zinc. That way, it covers the impurities that are on the zinc and then reduce the corrosion, or what we know as local action. And then for option D, make the cell black and hence a good radiator. Being a good radiator has nothing to do with the context of this question at all, so it's completely out of it. So that means the correct answer is option C, to prevent polarization. Now, folks, you can practice and get even better when you use the Exam Fund app. The link to download the app is added to the description box of this video. Kindly click the link and download the app and infuse some fun into your study time. And in case you have any question at all, perhaps on what we are doing, or during your study time you came across something that you need more clarity on, please put it in the comment section. We'll definitely attend to all of your comments. And please do not forget to subscribe to the channel. Always like our videos and also share them with your contacts so that we can reach a wider audience. I want to say thank you for being part of the series so far, and thank you for always sharing our content. I'll see you in the next video.